All right, number 42 from the practice final. A jar contains red marbles and green marbles. Ray randomly chooses one marble and places it in his pocket, then randomly chooses a second marble to find the probability that the first marble is red and the second marble is green. Which multiple choice shows the proper procedure? So what we need to understand is they are grabbing, there's more than one thing being chosen. So once we know there's more than one thing being chosen, we're talking about an AND situation, and an AND situation means to multiply. So if you look at the chart here, they pull a red one, okay, it's 1 over 2, 50% chance. And they're saying if you pick a red one, then you pick another one, it's a 1/3 chance it'll be red again, and it's a 2/3 chance it'll be green. And they want to know what's the probability of pulling a red one, then a green one. So it's this one times that one. So 1/2 times 2/3, and that would be B. 44. 44 says, what is the value? Okay, there's our sigma or our summation, right? It's the value of this and of I. Okay. So once this means to sum it up, right? So we're going to use, it's some sort of particular summation. So we got a couple of options for formulas. We've got the geometric one and the arithmetic one. Well, this is not in a power, right? So when the variable is in a power, that's when you know it's geometric. So this is not geometric, so we're going to use this one right here. This equals sum. Well, this is the first term, this is the last term, and you find this term by plugging in a 1 into this equation. This is an equation, it's really simple. This right here, if this helps anybody, I know I don't like this example, but this one was created from using this. It just so happened that everything's simplified to just, you know, n. I use n in this case, but just I, right? So we need to know, if I put a 1 in right here, that'll give me the first term. So a sub 1 is when I equals 1, and that equals just plugging it in, it's just going to be 1, right? And then a sub 15, which is the very last one, which is going to go right here, that's when I equals 15. If I plug that in, it's just 15. Okay? So that means I'm using this formula. That's going to be the 1, that's going to be the 15. So the question is, now what does this n represent? This n represents how many numbers are in the series. And it goes from where n equals 1 to where n equals 15. So if I subtract these and add 1, that's 14 plus 1, that's 15 over 2. So this equals 15 over 2 times 16 over 1. A little cross canceling here. I can do 8 times 15. That comes out to be 120. Alright, so that would be the sum of that finite series. 46, what is the sum? Well, if you look at 46, you can see that it goes on forever because you see the dot, dot, dot. So this is an infinite sum scenario. Well, infinite sums have limitations. The absolute value of r has to be less than 1. So basically, just look at the sequence. Okay, it's a series because we're technically adding them. And see if, make sure that it is geometric. And since these signs alternate, that's a dead giveaway for sure. And so we know it's geometric. We'll double check right now by checking the r's. Also, it has to be getting smaller. If you want to know if r is less than 1, see if the numbers are getting smaller. And their absolute values, I mean by that. So 6, 1, that's smaller. 1, 6, 136, that's smaller. So r in this case will be right over left. Okay, let's just test one more to make sure that it is actually a series. And then if I do this one here, I'm basically looking at this equaling negative 1 over 6. Okay. Times negative 1, and that equals negative 1, 6. Oh, that doesn't look very good, does it? These r's don't match. Well, let's check one more just to be double sure. Negative 1 over 36 divided by positive 1, 6. And we're basically looking at, I think I made an error up here. This one actually should have been 1, 6. So yeah, we're okay. We're okay. All right. Just double checked it to be sure. So my r is to rewrite that, -1/6. Because I should have inverted and multiplied. So I got that. All right, well, it's an infinite sum because it goes on forever. Dot, dot, dot. It's kind of segmenting some room here. So this is the formula for infinite sum. And this is less than the absolute value of 1. So this is going to equal a sub 1 all over 1 minus r. So s equals 6 all over 1 minus -1/6. That's going to be plus. And speeding this up a little bit. This is I'm going to treat this as 6 over 6. So it's just the 1. And then we get 7 over 6. Invert and multiply. Means the 6 comes up top over the 7. All right, flipping that upside down, and we're looking at 36 over 7 is the infinite sum. All right. And that was question 46. Question 48. Question 48 says find the common ratio, and this sequence is like such. So the signs are changing, so we know if it is a sequence, okay, it's got to be a ratio, and it's got to be geometric. And they're also saying ratio, so that tells us that it's geometric also. And so that's what we're gonna do, right over left, and that equals -1/2. Let's check one more here. -1/4 all over 2. That equals -1/4 times 2 over 1. And that also equals -1/2. So the common ratio is -1/2. You don't need to do 2. I just did 2 just to make sure I didn't make a mistake like I did last time. But just to be double sure. And then 50. Number 50 says using summation notation to represent the following. So you want to basically turn this into basically like question 44. Dot, 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 120. Okay. So let's see if we can remember how to do this. You need some rule here, right? And this is going to come from that rule. Since this is +3, +3, +3, this is arithmetic, so it's going to come from this formula right here. Okay, I'm going to figure out what this is. Okay, whatever that is, that goes right there. Okay, this is not, what goes on top are not a sub n's, meaning if you use a number from the sequence right here and right here, you're already wrong. This is from the first number to the last number. Okay, so the last number is 105. Okay, but I don't put 105 on top. I put what number 105 is in the series. A sub n is 105. What's the n for that? All right, so it's all going to come from right here. So we know a sub 1, that's right there. So we're going to say a sub n equals 3 plus n minus 1 d, and that's plus 3. So using this will give me any number in the sequence, right? So I want to figure out where we start. We know that's n equals 1. So I need to figure out, okay, what number is 105 in the sequence? Okay. If you're pulling a number from the sequence, it goes for a sub n. And now I'll find n, that'll tell me which number 105 actually is in the sequence. So we're looking at 105 equals 3 plus 3n minus 3. Those go away. Okay. And we're looking at dividing by 3. And then n equals 2, goes in there 3 times, I want to say 35. Right. 105 divided by 3 is 35. Okay. So we know, now we can actually answer this question. This goes from where n equals 1 to where n equals 35, because that's the last number, right? That's a sub 35 up there. Okay. Now we need the rule, and the rule comes right here. We need to simplify this down, and actually you can see it turned into just this, 3n. So you'd pick your answer from right there. Okay. Number 52 is a little bit of binomial expansion. two more here. And we're looking at 2x plus y to the fifth. Well, you can use Pascal's triangle here if you want, if you can remember all the way down to 6 terms. And how do I know this is 6 terms? Because it's always one more than that. But in this case, I would probably use the combination formula. And I can tell, I can actually, I'm going to put the answer, the question here. I can do this question without having to do all of them. Because if you look at it right here, the first terms for A, B, and C are different. C and D are the same. So by me just doing the first term, I can figure out, I can eliminate at least 2 of the options. All right. If I look at the last terms on all of these, they are all different. For these 2 here anyways, I had the 2 first terms. So I'm just going to do the first term and the last term coefficients and see if I can eliminate it that way. So here we go. This is 5 terms, so this is going to be an example of C, 5. You always start from 0. That's my A term, and that's my B term. And remember, this number and this number are always the same. They need to add to 5. So that's my first term. Let's figure out what that equals. And my last term is when I give myself a little bit of room, is when I'm right here. And that's where, remember, this term has to be that, and it has to be 0. So let's work these out and see what happens. These are our first terms and our last terms, and we can eliminate all the other ones. So we're looking at 5 factorial all over 0 factorial times 5 minus 0 factorial. So we're going to get 5 factorial over 5 factorial, so that comes out as a 1. Okay, so that's 1, and Pascal's triangle tells us that. And then we got 2 times 2 to the 5th, x to the 5th, y to the 0, right? So this turns into 32 x to the 5th. And I go back to my C and D. Okay, so it's got to be C or D looking at the answer key. I'm looking at the questions. Then I'm going to look at the last term here, and I'm going to get 5 factorial all over 5 factorial times 5 minus 5 factorial. And I'm going to get 5 factorial all over 5 factorial times 0 factorial. Remember, 0 factorial is 1, so this all turns into 1. Okay. Then I have 2 to the 0, x to the 0, y to the 5th. So these all turn into 1s, and I'm basically left with y to the 5th. So I'm looking at C and D, and the only one that has the right first term and last term for 52 is C. All right, try to finish this last one here. Number 54 says they want to know the 5th term. So remember here, there's 7 of them. So you're looking at, you always start from 1, and you're going like such, right? So here's 1, 2, 3, 4, 5. That's our 5th term. So we'd want basically this right here. Okay, that's our 5th term. And the first part of it is A. And be careful here, the second term is negative B, not B. And this one and this one have to match. And remember, since we start from 0, if they want the 5th term, it's when R is 4. If they want the 10th term, it's when R is 9. Right? And they need to add to 7, so that one's 3. So this is going to turn positive here because it has an even power. So 7 factorial all over 4 factorial, 7 minus 4 factorial all over times a to the 3rd b to the positive 4th, and I'll leave that for you to continue working that out. Give you one more step here. A to the 3rd b to the 4th. All right, and work that out.